Now let us consider the next question. It is also a matching type question, but there are three columns. First column, the respective ions or the salt, as the case may be. Y, the corresponding reagents. Z, the precipitates that are formed. Now, if you notice here, first let us consider A, K plus ion. For K plus ion, look at column Y. What will be the reagent which will react with K plus ion? It is sodium cobalti nitrite. This is the reagent for testing the presence of K plus ion. Please remember, K plus ion reacting with sodium cobalti nitrite will give as the product potassium cobalti nitrite. Sodium cobalti nitrite reacting with K plus ion will give the corresponding potassium cobalti nitrite, which will be yellow in color. Potassium cobalti nitrite will be yellow in color. So, A, K plus, C from Y, and 6 from Z. So, this is how you have to match. Similarly, consider ferric ion. In the previous problem, I have told you ferric ion with thiocyanate ion gives a blood red coloration, a color resembling that of blood. Fe3 plus B reacting with thiocyanate ion E to give a red precipitate 1. So, for B, matching will be in the form of E from Y and 1 from Z. Similarly, consider cupric ion, Cu2 plus. Now, in this connection, I want to mention one point. Usually, cupric salts are colored, whereas cuprous salts are colorless. Most of the cuprous salts are found to be colorless in nature. All right. You see, in group analysis, in qualitative analysis, to confirm the presence of various ions, we are performing several tests. For example, we are adding ammonium hydroxide to cupric ion solution, or potassium ferrocyanide, and so on. So, you look for the presence of the particular reagent that is given under column Y. Ammonium hydroxide is not given in column Y. So, you resort to ferrocyanide ion. Usually, we give the compound as potassium ferrocyanide, but here I have mentioned only ferrocyanide ion. Usually, cupric ion reacts with ferrocyanide ion F from Y to give a chocolate brown precipitate. Cupric ion with potassium ferrocyanide will give a chocolate brown precipitate, which is 4. Then D, mercuric chloride solution. Mercuric chloride solution will react with what is the reagent given. Already this is we have seen, this one we have seen, this one also we have seen. The remaining 3 reagents, starch solution, HCl and excess Ki. Now, here there is a slight twist under column Z. All right, we can confirm the presence of mercury in two ways. One is mercuric ion plus stannous chloride reaction. That is one possibility. Or the second reaction for mercury is addition of Ki solution. Now here mercuric chloride plus Ki will give a red precipitate to start with. Now here stannous chloride is not given, but Ki solution is given, but it is mentioned as excess Ki. When you add Ki solution, first, if mercuric ion is present, mercuric iodide is precipitated as a red precipitate, a red compound. So immediately don't come to the conclusion that one is the correct answer. Here it is given excess Ki solution. That means HgCl2 plus Ki will give, to start with, Hgi2, red precipitate. But this Hgi2 precipitate dissolves in excess of Ki. That means red precipitate will dissolve to give a clear solution. But under column Z, a clear solution is not given. Red precipitate is given, but that is not the correct answer, because it is excess Ki that is used. That means the clear solution is K2HgI4. This is a colorless solution, but here in the answer it is not given. But another answer is given, namely Nessler's reagent. This clear solution containing K2HgI4, you add to this NaOH. That is known as Nessler's reagent. So, for D, mercury chloride, A from column Y, and not 1 from column Z, but it is 2. Because the clear solution you are going to get plus NaOH forms what is called the Nessler's reagent. All right, come to E. Lead nitrate solution, aqueous solution, AQ aqua. Lead nitrate dissolved in water. So it is also. Now, lead nitrate, one of the tests for lead ion is addition of hydrochloric acid. For lead salts, if you add hydrochloric acid, lead chloride is precipitated. Lead chloride is white in color, so white precipitate is given here. So for E, B from column Y and 3 from column Z. Then last one, F. Aqueous iodine solution, and this aqueous iodine solution will react with the only reagent that is left out is starch solution, D. This will give blue, a blue coloration. So iodine aqueous solution with starch gives this blue coloration. So in this matching, I have chosen the ions or the salt, as the case may be, then the corresponding reagents, and the last column the color of the precipitate or the name of that particular solution, which is given like Nessler's reagent and so on. So I have given the answers at the bottom.